Predictive parser. Predictive parser is also called as LL1 parser. It is a type of recursive descent parsing with no backtracking. It can be implemented non-recursively with the stacked data structures. It is also known as non-recursive descent parser or LL1 parser or LLK parser. So predictive parser itself is also known as non-recursive descent parser, LL1 parser or LLK parser. It accepts LL grammar and it is denoted as LLK. In LLK, the first L represents that the scanning of the input will be done from left to right, and the second L shows that in this parsing technique we are going to use leftmost derivation, and the K represents the number of look ahead symbols. So LLK. So in this, the first L represents the input we are going to scan from left to right, and this L represents we are going to use the leftmost derivation, and the K is nothing but number of look ahead symbols we are going to use. So generally we are going to use the look ahead symbols as 1. A grammar G is LL1 if there are two distinct productions. That is, for example, consider the grammar as A tends to alpha beta with the following conditions. For no non-terminal alpha and beta, derive string beginning with A. At most, one of alpha and beta can derive empty string. If beta tends to epsilon, then A does not derive any string beginning with a terminal in follow of A. The data structure used by LL1 are input buffer, stack and parsing table. So this is the structure of LL1. So LL1 parser, we are going to give the input from the stack. So in stack, the first starting symbol we have as dollar. Okay, and then insert the starting symbol in the production. So this is given as the input to the LL1 parser. So the input, this is the stack, and this is the input buffer. For the input string, we are going to give a dollar symbol at the end of the. So we are going to use dollar for the given input string at the end, and so we are going to get this. This is the parsing table, and we are going to write all the non-terminals here and all the terminals here, and here we are going to get the output. So this is how the structure of LL1 works. We are going to have a stack, and we are going to give the input, and then the parsing table we are going to construct, and then finally we are going to parse the input string. Construction of predictive LL1. So in order to construct a predictive LL1, we are going to consider the following steps. That is elimination of left recursion, left factoring, construct first and follow functions, construct predictive parsing table, and parse the input string. So first thing is elimination of left recursion. So elimination of left recursion is nothing but if both left hand side and right hand side we have the same symbol, it is called as a left recursive. In order to remove the left recursion, we follow these steps. The first thing is, the first step, you need to write all the non-recursive productions from the given input string, and then we need to introduce a new symbol related to the starting symbol, and for that new symbol which we have introduced, you need to write the given, you need to derive it. So for that, what we need to write all the symbols except the repeated symbol, whatever the symbols are there, that we need to write, and then write the epsilon. So here consider A tends to A alpha or beta. So here alpha and beta are strings. So here A tends to, the non left recursive production here is beta, So A tends to beta, and introduce a new symbol, that is A dash. A tends to beta A dash. For this A dash also we need to derive. So A dash tends to, what is the step I told here? Write all the remaining symbols except the starting symbol. So the remaining symbols we have here is alpha, and then write the newly introduced symbol, and then write epsilon. This is how we eliminate the left recursion. And then left factoring, you need to, if there is any left factoring, we need to eliminate the left factoring. So left factoring is nothing but, in a given production, if there are more symbols starting with the same production, that is called as the left factoring. So we will have a confusion like which production rule to use first. So consider an example, A tends to alpha beta 1 or alpha beta 2. Here we are having same symbols, alpha we are having. So this is called as left factoring, and we need to remove the left factoring. In order to remove the left factoring, first we need to write all the common symbols from the given production. So in this given production, the common symbols are alpha. So we need to write A tends to alpha, and then introduce a new symbol A dash. A tends to alpha A dash. So we need to derive for this A dash also. So for that, what we need to write all the remaining symbols from the production. A dash tends to beta 1 and beta 2. So this is how we eliminate the left factoring. And the next step is calculating the first and follow functions. So how to calculate the first and follow functions? Finding of first and follow. First and follow sets are needed so that the parser can properly apply the needed production rule at the correct position. So in order to calculate the first function, so first of alpha is a set of terminal symbol that begins in strings derived from alpha. Example, A tends to A, B, C or D, E, F or G, H, I. So then first of A is nothing but what we need to write all the terminal symbols. First of A, what are all the terminal symbols? A, D, G. So in the given input grammar, considering the first of that is nothing but, we need to write all the first terminal symbols. Terminal symbols are nothing but all the lowercase alphabets. So here the starting symbol is A, that is lowercase. So this is considered as first of A, and here D we have, and here G we have. We need to consider only the first terminal symbols. Rules for calculating the first function. The first rule is, for a production rule, if the production rule is in the form of x tends to epsilon, then first of x is equal to epsilon. For any terminal symbol A, so then first of A is nothing but that symbol itself. And next, for a production rule, if a production rule is in the form of x tends to y1, y2, y3, if epsilon does not belongs to first of y1, then first of x is equal to first of y. If epsilon belongs to first of y dash, then first of x is equal to first of y1 minus epsilon union first of y2, y3. Then calculating first of y2, y3. So first of y2, y3, if epsilon not equals to first of y2, then first of y2, y3 is equal to first of y2. If epsilon belongs to first of y2, then first of y2, y3 is equal to first of y2 minus epsilon union first of y3. Similarly, we have to expand the rule for any production rule which is in the form of x tends to y1, y2, y3, so on till yn. So if we does not understand these rules, let it be. While considering the example, you will clearly understand. Then rules for calculating the follow function. Follow of alpha is a set of terminal symbol that appear immediately to the right of alpha. So consider here S tends to AAC, A tends to BD. So first of S is nothing but all the terminal symbols, the first terminal symbols in that. So the terminal symbol here we have is A. So first of S is A and first of A is B. Now consider follow of A. So follow of A is nothing but, the terminal symbol which we have after that symbol. So for A we want to calculate follow function. So after this A, whatever the terminal symbol we have, that is called as the follow function of that symbol. So after A we have a C. So follow of A is equal to C. And the rules for considering this is, for the start symbol S, place dollar in follow of S. So for the starting symbol S, we need to write dollar first. We need to place dollar. It's mandatory. Follow of S is nothing but dollar. So follow of starting symbol is nothing but dollar. For any production rule A tends to alpha B, if any production rule is in the form of A tends to alpha B, then follow of B is nothing but follow of A. So here these are all non-terminals. A is a non-terminal, B is a non-terminal, that is uppercase letters. So follow of B is nothing but again the follow of A. For any production rule A tends to alpha B beta, if any production rule is in the form of A tends to alpha B beta, if epsilon not equal to first of beta, then follow of B is equal to first of beta. If epsilon belongs to first of beta, then follow of B is equal to first of beta minus epsilon union follow of A. So these are the rules for calculating the first and follow functions. There are some important points which needs to be considered here. Epsilon may appear in the first production of a non-terminal. Epsilon will never appear in the follow function of a non-terminal. So epsilon may appear in the first function of a non-terminal, but epsilon will not appear in the follow function of a non-terminal. It is recommended to eliminate left recursion from the grammar if present before calculating the first and follow functions. We will calculate the follow function of a non-terminal by looking whether it is present on the RHS, that is right hand side of the production rule. So these are the rules for calculating the first and follow functions. Let us consider an example. S tends to A tends to AB or AD, B tends to B, C tends to D. So we need to calculate the first and follow functions for this given grammar. So first step is what? To check whether, we need to check whether the given grammar is having left recursion or not. So check whether the given grammar is left recursive or not. So this grammar is left recursive because here A, we have the starting symbol A, and here also we have the symbol A. So that means it is left recursive. So you need to eliminate the left recursion. So after eliminating the left recursion, the grammar becomes as S tends to A tends to AB, S tends to, A tends to AB, A dash, and A dash tends to D, A dash or epsilon. And here we are not having any left recursion. B tends to B, C tends to G. Now calculate the first function. So first of S. So first of S is nothing but first of A, because we are not having any terminal symbol here. So again we need to consider first of S is nothing but first of A. So first of A, calculate for this. First of A is nothing but, here we have a terminal symbol A, so we are considering A as the first of A. So first of A is A, and first of A is A. First of A dash is D, and here again we are having epsilon. So D comma epsilon, first of A dash. First of B is B, and first of C is G. Now calculate the follow function. So follow of S, for the starting symbol dollar is the follow function. For that, follow of S is equal to dollar. Now follow of A. Follow of A is equal to, so follow of A is equal to follow of S. So consider here, follow of A is equal to follow of S. So again the follow of S is dollar. So we have written dollar, and follow of A dash. Follow of A dash is equal to, so see here, follow of A dash. So follow of A dash. So after A dash we doesn't have anything. That is again we need to consider. So here we are having, when considering follow functions, you need to check this side. So follow of A dash. After A dash we are not having anything here. So again we need to go for follow of A. Follow of A dash is follow of A. So follow of A is what? So follow of A is dollar. So follow of A dash is equal to follow of A is equal to dollar. Now follow of B. So follow of B. Check here. Where is B here? He. Follow of B. After B what we have here? A dash. So follow of B is nothing but, here we need to apply the formula here, because here follow of B is nothing but first of A dash minus epsilon union follow of A. So for first of A dash is what? First of A dash is D comma epsilon. So first of A dash is what? D comma epsilon. So D we are writing here, and epsilon we are doing minus, and then union follow of A. Follow of A is dollar. So follow of B is nothing but D comma dollar. And next follow of C. So follow of C. So this side we are not having any C. So that is, this is not acceptable. So follow of C, we cannot accept the follow function. So whenever considering the follow functions, you need to check this side. We will be considering for all this. So wherever the symbols are there, you need to check this side, and from this you need to check whether anything is following that function or not. A, after A what is following. So that we need to write here. So after calculating the first and follow functions, I have written like this: the productions, first and follow functions. S tends to A tends to AB A dash tends to DA dash or epsilon, B tends to B, C tends to G. So the first functions are, whatever we have calculated there, that I have written in this tabular format. Now, so first function for S tends to A is A, and the follow function is dollar. And here A tends to AB A dash, the first function is A and the follow function is dollar. And A dash tends to DA dash or epsilon, the first function is D comma epsilon and the follow function is dollar. For B tends to B, the first function is B and the follow function is D comma dollar. For C tends to G, the first function is G and the follow function is not applicable. So after this, we need to construct the parse table by using the first and follow functions. So here we need to write all the non-terminals, and here we need to write all the terminals. So here whatever the non-terminals are there, that we need to write here: S, A dash, B and C. And whatever the terminals are there, you need to write here. The terminals from the given grammar is A, D, B, G and dollar. So now check here, S on A. So the given production S on A. Check here, the production S on the terminal A. By using what production we have got this? By using the production S tends to A. That you need to write here, S tends to A. Now S on D we doesn't have anything, so I didn't write anything. S on B we don't have anything, and S on G we don't have anything, and S on dollar also we don't have anything. Next, A on A. So A on A, what, by using what production we got this A on A? A tends to A B A dash. So I need to write here A tends to A B A dash. Next, A dash. A dash on what we have here, A dash on D and epsilon. So in place of D and epsilon, you need to write this production. So in place of D and epsilon, in that is nothing but epsilon we are not considering, so we are writing dollar also here. So in place of D and dollar, you need to write this production. A dash tends to D A dash, and in place of dollar we are writing A dash tends to epsilon. And next B tends to B. So what is the first and follow we have here? B. And so for this we need to write, in place of B you need to write B tends to B dash. In place of B we need to write B tends to B dash. The next production is C tends to G, and the first function for that is G. In place of G we need to write C tends to G. In place of G we need to write C tends to G. This is how we construct the parse table using first and follow functions. There is nothing here. By using this production and the first function, if there is epsilon in the first function, consider the follow function. In the place of that follow function we need to write this production. If there is no epsilon, then no need to consider the follow function. Consider only the first functions and check in this place of the first functions, that is in place of this terminals, we need to write this productions in the parse table. And the next one is stack implementation by using the parsing table. By using the parsing table, we need to implement this stack. So the given input string is ABD dollar. So you need to consider stack, input and production. So in stack, first we need to insert the dollar. Okay. And then consider the starting symbol as S and write the input string ABD dollar. Now consider S on A. By using this table, you need to derive that. Now check S on A. By using which production we got here? S tends to A. Okay. So see here, S on A. So write the production here. S tends to A. That means this S will be replaced with A. So in place of S, I am writing A and the dollar. Now A on A. A on input A. So check here. A on input A. What we got, from which production we got here? A tends to AB A dash. So here in place of production you need to write A tends to AB A dash. So this A is substituted with AB A dash. A is substituted with AB A dash. So here the input string we have ABD dollar. So A and A are being matching. So we need to pop this. Pop A. And next the remaining you need to write B A dash dollar. Next the remaining input string BD dollar. Now B on D. Check here in this given table. B on D. What we have here? B tends to B dash. So B on B, what we have here? B tends to B dash or B tends to B. So in place of B, we need to substitute it with B. And here we have B here. So what we need to do? Pop. We need to do the pop function, that is pop B. We need to strike off that and write pop B. Write the remaining stack. A dash dollar and here D dollar. So A dash on D. So check here. A dash on D. The production is A dash tends to D A dash. So A dash on D, the production is A dash tends to D A dash. So right here in place of A dash, you need to substitute it with D A dash. And here write the input string D dollar. So we have the same symbols D and D. So we are doing the pop operation, pop D. So the remaining symbols are A dash dollar. So here the input string is dollar. Now A dash on dollar. Check here. A dash on dollar. A dash tends to epsilon. You need to write A dash tends to epsilon. So epsilon, you need to substitute a epsilon in place of A dash. Epsilon is nothing but nothing. So nothing. Write dollar here. Input is dollar. So dollar, dollar, accept. that is accept. The input is properly parsed. So after parsing this, we need to construct the parse tree, generate the parse tree using stack implementation following top down approach. So S tends to A tends to AB A dash, B tends to D, A dash tends to D A dash, and A dash tends to epsilon. So the given input string is ABD. So we have derived the given input string and the string is successfully parsed. So this is how we implement this.